Now, if there is no acidic hydrogen, then in this case, the carbon ion of the Grignard or the alkyl lithium, both they are the same reactivity in there. Both are going to act as a nucleophile now. So there is no acid-base reaction here because in these reagents there is no acidic hydrogen. So they're going to act as a nucleophile, and the nucleophiles always attack the electrophilic site. In this case, the electrophilic site can be either the carbon that is on the carbon dioxide in there. This is the electrophilic site. The way to know the electrophilic site is just follow the direction of polarization. So if you have a carbonyl in there, we already know that the oxygen is electro and negative. So if the oxygen is electronegative, then the oxygen is going to pull electrons away from the carbon in there, making that carbon an electrophile. So now I know that my electrophilic site is going to be this carbon. This means that if there is any nucleophile in the solution, the nucleophile is going to come and attack that carbon in there. Same thing for the epoxide. The oxygen is an electronegative element. So in this case, your direction of polarization is towards the oxygen. This means the pull of electrons. Oxygen is pulling the electrons away from these two carbons, leaving those two carbons electrophiles. So this means that the carbon ion is going to attack any of those carbons depending on how substituted they are. This is ring opening of the epoxide that we've talked about in Organic 1, Chapter 8. But we will review that as well here. So carbon ions can attack any electrophilic site. Also, carbon ions can attack alkyl halides because alkyl halides have an electrophilic site in there due to the electronegativity of the halogen. So any of these carbon ions are going to come attack the R. Any one of those are going to come attack the R, and X is going to leave. So you are going to end up, in this case, your product is going to be an alkane. You're going to make a bond between this R and this R over here. Let's start with the first reaction of Grignard or alkyl lithium with carbonyls. We've considered these reactions in Chapter 8 in Organic 1. We are going also to review them in this chapter. So let's go ahead and have an example. Let's say, for example, if we have a carbonyl and we're reacting it with a simple Grignard. This is the CH3MgBr. The reaction is going to go as follows in here. It's two-step reaction. The first step, you use the Grignard. With the Grignard, you should use a solvent that has no hydrogen whatsoever. No water should be involved. This is why we use the diethyl ether in there. This is going to be the first step of the reaction. The second step is a simple solvent that has a hydrogen after we're done from the attack of the Grignard. So start by breaking your charges over here and introduce your R of the Grignard. Make it simple. So the R of the Grignard here is a carbon. It's a CH3. So this carbon has a lone pair and a negative charge. This is what? This is a nucleophile. Why it's a nucleophile? Because there is no acidic hydrogen whatsoever over here for this to act as a base. So this is why it acts as a nucleophile. So the nucleophile is going to come, it's going to attack the carbon and form a negative charge on the oxygen. Again, why it's attacking this carbon? Because this carbon is partial positive, this oxygen is partial negative, due to the direction of polarization from the electronegativity. So what I'm going to end up getting in this case is a simple addition. This is an addition reaction. You added the CH3 over here, and you formed a negative charge on the oxygen. Now we're done from the Grignard. The Grignard added, so I don't need this anymore. Once you're done from the Grignard, then the next step of the reaction, this is step 2 of the reaction, we're going to use a solvent. The solvent in these cases is either water or H3O+. It's any one of those solvents in there. I'm going to use the H3O+. This is the hydronium ion. And H3O+ is a product of any acid that is dissolved in water. Or I can simply use water. both are going to be the same, but because the only role of the solvent at the end is it just to protonate that oxygen by doing an acid-base reaction. So if I use water, then this is going to be my base, and this hydrogen here is going to be my acid. So it's a very weak acid. Or I can use the base with this acidic hydrogen over here. Water is going to leave. This is the OH is going to leave in this case. Any one of those. And then my product is going to be an alcohol. The rule says that if I start with a ketone, then my product is going to be a tertiary alcohol. If I start with an aldehyde, for example, let's go ahead and start with an aldehyde. So if I start with an aldehyde and I react this with any R, so I'm going to go ahead and use phenyl magnesium bromide with diethyl ether. This is going to be my first step in there. So we agreed to break it, make it simple, and it's this carbon that is connected to the magnesium, this carbon over here. So I want to make this carbon over here lone pair with a negative charge. So this is the carbon over here that was connected to the magnesium. So I want to make it a lone pair with a positive charge. So now this is going to come, it's going to attack the carbon and form a negative charge on the oxygen. So you're going to end up having your own negative. You already have a hydrogen, but you added what? You added a benzene. This is what you added. So put it like that. Okay, it's either you put it as a benzene or you use the abbreviation, which is the pH. Whatever whatever best for you, you can go ahead and do. Now the second step of the reaction, I'm going to go ahead and use the water to protonate the oxygen. So you're going to see over here that what I ended up getting is simply a secondary alcohol. So this is going to be my secondary alcohol in this case. If you work backwards, then what you need to do is highlight the carbon OH in there. So the carbon OH is the carbonyl. Just go backwards, because sometimes you are given the alcohol and you are asked, go ahead and find out the carbonyl and the Grignard reagent that it came from. So you highlight the carbon OH and immediately change that into a carbonyl, and then go ahead and break the bond between the carbon and your R group. Here in this case, you have two R's. It's either the side that can be the R of the Grignard or the side that can be the R of the Grignard. So if you choose this side to be the R of the Grignard, make this side the R of the aldehyde in there. Of course, you need to know that this is a secondary alcohol, and secondary alcohols, they always come from aldehydes. So tertiary alcohols, they come from ketones. Secondary alcohols, they come from aldehydes. Now, if I wish to make a primary alcohol, then in this case, I need to have hydrogens over here. I should not have any R in this case, except the R of the Grignard that I want to add. So I need to start with the simplest type of aldehyde, which is the formaldehyde. So that is the simplest type of aldehyde here, which is formaldehyde. And you go ahead and you react that with the Grignard. We can react the Grignard, as I said, with, let's say, for example, MgBr, okay, and diethyl ether, and this is step number 1. So it's this carbon over here that is connected to the magnesium. So we're going to go ahead and make this carbon a negative charge. Don't forget it's CH3. It's this carbon over here. So this is going to be our nucleophile, and that nucleophile is going to come, attack the carbon, form a negative charge on the oxygen. These hydrogens are not acidic. So this is not going to act as a base and take any of these hydrogens in there. It's just going to act as a nucleophile, attack the partial positive carbon, form a negative charge on the oxygen, and you're going to end up having your own negative in there. you have your hydrogens, and all what you did is just you added your triple bond in the CH3. So this is your R in here. You do the protonation, which is the water, and this is going to be your second step, step 2 over there. I am putting step 2. So in each one of those, you have to put step 2 there. And then the lone pairs are going to come, take the hydrogen, OH is going to leave, and you are going to end up getting your primary alcohol in this case. So this is going to be the primary alcohol. So based on the type of the alcohol that you are getting, you can easily know what type of carbonyl you started with. So primary alcohol means that I'm always going to start with formaldehyde. This means that the R over here needs to be the R of the Grignard. Secondary alcohol, it's either one of the R's is going to be the one for the Grignard, and the other R is going to be for the aldehyde and not the ketone. 4 ketones in there, you're producing tertiary alcohol. So choose one of the R and make it for the Grignard, and the other 2 R's, make them for the ketone in there. They can be any of the 2 R's, a CH3 and an ethyl, or 2 CH3s in there. Any of these 2 R's can be the R's of the ketone. There's another way of getting the tertiary alcohol, and that way is to start with an ester or an acetic chloride. So let's say if we start with an ester, okay, and we are reacting this with still phenyl, magnesium, bromide, in presence of diethyl ether. This is the first step in there. So now I am starting with an ester. Ester and acetic chlorides, they have something in common, which is the leaving group. So esters always have this guy over here, which is a good leaving group in basic medium. And this is a basic medium in there because whenever I draw the Grignard, the R of the Grignard, this is a negative charge. It is a nucleophile, so the medium is not definitely acidic, it is basic, and oxygen can leave in a lone pair in a basic medium. So the reaction is going to proceed by having the nucleophile attacking the electrophile. This is partial positive. This is my nucleophile in there, forming a negative charge on the oxygen. The Grignards are very reactive, very reactive. So the Grignards are going to keep reacting as long as you form a carbonyl. So notice here what I have. I formed a negative charge and I added a phenyl group. I'm just going to write it as a pH. So I added a benzene over here. Now I'm going to go ahead and do resonance to kick out the OR. And this always happens with esters because, again, as we said, the ORs are a very good leaving group. So it's going to form a double bond. This is going to leave, and you're going to end up getting, this is a carbonyl, and it's going to be a phenyl. So see, you're back now to a ketone. So always the intermediate in the reaction of the esters before getting your final product is the ketone. Now, you cannot stop here. So as if you are back to here, over here. So this is why the Grignard is going to react again. Grignards are very reactive. They're going to keep reacting as long as you are forming a carbonyl. Once you stop forming a carbonyl, this is when you proceed to the next step of the reaction, which is the protonation. So since I formed the ketone in here, I'm going to go ahead and react this with the same Grignard again. Here you go. So I don't have to mention that the Grignard is used in excess because the Grignard is very reactive. As we said, it's going to keep reacting as long as there is a carbonyl. In some reactions, you're going to see that this one is expressed in excess. In some reactions, you're not going to see it in excess. It really doesn't matter. It's always in excess. So this guy over here now is going to come. It's going to attack the carbonyl, form a negative charge on the oxygen. Now the only difference here is that I don't have an additional leaving group in here. So, but I ended up adding the phenols twice in there. And these two phenols here, they belong to the R of the Grignard in this case. So now my second step I'm done. My second step is going to be the protonation with water or H3O plus, and this is going to, my arrows are in the opposite direction. The base is going to come take the hydrogen form, the OH in this case, and I'm going to end up getting my product, which is going to be the tertiary alcohol. You know that your tertiary alcohol is coming from an ester if you have two R's that are the same on the alcohol. But it doesn't really matter because tertiary alcohols are always products of ketones, esters, and acidic chlorides. So let's say, for example, if we substitute the OR by a chlorine, so now we are doing an acidic chloride, the mechanism is going to proceed exactly the same, but the leaving group now is going to be a chlorine instead of the OR. And you're still going to get the tertiary alcohol as a product. There are extra problems in the notes and in the problem set. Practice those, please. Let's have another example, this time with cyclic ethers. You are responsible for the mechanism of these reactions. So let's say, for example, if I have something like this, and I am reacting this with, let's say, our Grignard in there. So this is an MGBr, in presence of diethyl ether. So we're going to do it as two steps in there. Let's go ahead and start with the first step of the reaction. This is going to be your carbon ion in there. Make sure to count all the carbons. Don't miss any. So I have a carbon over here. Now, since I don't have no acidic hydrogen in there, this is going to behave as a nucleophile. And the nucleophiles attack the carbon of the carbonyl because it's this carbon that is an electrophilic site in there. This is our partial positive carbon. So now the nucleophile is going to come and attack the electrophilic site. Every time I make a bond, I break a bond. Okay? So my product in this case is going to be an oxygen. Pay attention to the octet. Every carbon needs to have 4 bonds and not more than that. So I'm going to end up having, I didn't break my cycle yet. So with these reactions, normally I break the cycle of the ester, but I didn't break it yet. All I did is I added on this carbon my auto group. So I made a bond between this carbon and this carbon over here. This is a double bond, so you have to write your double bond in there. And then I have on the double bond, I have 2 carbons coming out of it. So this is a 2 carbons in there. This is a total of 4 carbons. It's 1, 2, 3, and 4. Count them. This is 1, 2, 3, and 4 in there so that you won't be missing anything. This is going to be the first step of the reaction. As we mentioned with esters, you do have a very good leaving group. It's an excellent leaving group over there. So this is going to go ahead and leave with resonance. So you're going to end up having resonance, and this is going to leave. Mechanism you are again responsible for. So now you're going to create the carbonyl back again. We already have our R group, the first R group that we attacked in there. And then the rest of the cycle, but now it's no longer a cycle in here. So this one is going to be an O. It is a negative charge. Oxygen, when it makes one bond, it is a negative charge in there. Don't forget any of your substituents. Here I do have 2 carbons. Let's go ahead and put the carbons in there. So from the first step over here, from the first addition of the first mole of the Grignard, I ended up, take a look, I ended up adding that first mole of the Grignards in there. So this is going to be the first mole, and I am back to my carbonyl in there. So this means that as long as there is a carbonyl in the solution, that Grignard is going to keep attacking again and again and again. So now I'm going to have another mole of the Grignard. So always you're going to assume that you are using excess of the Grignards with esters and acidic chlorides. So this is going to be always an excess because Whether it is in excess or not, the Grignard is going to keep attacking as long as there's a carbonyl in the solution. So we're going to end up having another mole of that Grignard in there. That Grignard again is going to come attack the carbon of the carbonyl and form a negative charge on the oxygen. So you're going to have a negative charge in there. But see now, you added your second mole of the Grignard. So both R's of the Grignard in there are going to be added. Here you go. And then the rest of the molecule in here. So now I don't have any other leaving a group. That's it. And it's now that I'm going to stop adding the Grignard anymore. So I'm done from the first step. No addition of the Grignard anymore because I cannot form a carbonyl. So the reaction is going to now continue. And now I am to the protonation step. I can either use an acid or I can use water, whatever that is, whatever solvent that has a hydrogen. And there I'm just going to go ahead and use an acid this time. Both of the oxygens will get protonated in this case, okay? And then I'm going to end up getting my product. That is going to be an OH now, so I'm going to end up having my product in there. That's going to be my first. This is going to be my second in there, and then the rest of the molecule. Notice that I started with a cycle, so here is again an OH. I started with a cycle, and now I ended up with a chain. Always with cyclic esters, I would end up breaking the ester bond. And the ester bond is simply the bond between the carbonyl and the oxygen. So this one gets broken. And on this carbon over here, I would add my 2 R's of the Grignard. And this oxygen in there is going to turn into an OH. And this one is going to turn into an OH in there. So I'm going to have 2 alcohols here. And the alcohol where I added my R's of the Grignard. So that is going to be the first R of the Grignard. This is going to be the second R of the Grignard in there. So the alcohol that I added the Grignards to, that is going to end up being a tertiary alcohol. And this is another way, as we mentioned, other than the ketone, of making tertiary alcohols. That same reaction also can happen if I am working with acid chlorides, for example. So if I am working with something like this is a chlorine in there, and I am using Grignard. Let's use a simple RMGBr. You know what? Let's go ahead and use alkyl lithium here. So let's use a phenyl and the lithium in presence of diethyl ether. It's going to be the first step of the reaction. So my R in this case is going to be my carbanion. That R is going to come. It's going to attack the carbon of the carbonyl, form a negative charge on the oxygen. This is your electrophilic site. So this is the partial positive carbon. So you have a reaction now between a nucleophile and an electrophile. Okay. Every time you make a bond, you break a bond. So over here, all I did is I added my R of the Grignard on this carbon over here. Okay, formed a negative charge on the oxygen, and I still have my chlorine. Don't forget about that. Chlorines are a good leaving group because these are weak bases. So I can easily do a resonance in this case, return this back to the carbonyl, and the chlorine is going to leave. So when the chlorine leaves now, I am back to the ketone again. So I am back to my carbonyl. But notice what I did over here. I replaced the chlorine with the R of the Grignard. As long as I have a carbonyl, as we mentioned, the reaction is going to keep going on. So I will be using another mole of that Grignard in there. Grignards are very sensitive to carbonyls. So this is why with acid chlorides and with esters, always the Grignards attack twice because you have leaving groups in there. So this one is going to be in excess, alkyl lithium in excess. So the R now in the alkyl lithium is going to attack again over here. So it's going to go and attack again. When it attacks again, it's going to attack the electrophilic carbon. This is the partial positive side, form a negative charge on the oxygen in there. So you're going to end up having an O negative. Always the product of these reactions is an alcohol. And the question is, are you forming the primary, secondary, or the tertiary alcohol? It depends on what carbonyl you start with over here. So this is going to be my carbon of the carbonyl, and I added here 2 R's now of the Grignard. So now I'm done. I'm going to go ahead and use the last step in the reaction using the acid or water. It doesn't matter, any solvent that has a hydrogen, and that is going to come protonate the oxygen. Water is going to leave. Notice again my arrow is from the more electron to the less electron, from the oxygen towards the hydrogen. This is called the protonation step, the last step in the reaction. And I'm going to end up getting a phenyl here, a phenyl there, and an OH. And this is again a tertiary alcohol. So as a summary, tertiary alcohols, they are made from either a ketone or an acid chloride or an ester. I can go with the reaction backwards. So let's say, for example, if you are given this alcohol and you are asked to prepare that alcohol over here. The first thing that you would need to do is take a look at what type of alcohol that you are working with. So check the type, and this is a secondary alcohol. It is a secondary alcohol because you look at the carbon that is having the OH and see how many carbons it is connected to. It's connected to 2 carbons, so it is a secondary alcohol. So now I know that secondary alcohols, they form from a reaction of aldehydes plus either alkyl Grignards or alkyl lithium, whatever you want to choose. It doesn't matter. Both are going to be the same. Now for the aldehyde, you can pick any R's, any of these 2 R's in there. It doesn't matter. So I'm just going to go ahead and pick all of this part over here, okay, to be my aldehyde. So you're going to change the carbon CO, the CO bond, you're going to change it into a carbonyl and make this whole thing an aldehyde. This is one way to do it. It's one route. We call it one path in there. So that is going to be a double bond O and a hydrogen in there. So the rest of the molecule now, this R is going to be the R of the alkyl lithium or the Grignard. So you're going to end up having this guy over here to be your alkyl lithium or the Grignard. Or I can go ahead and pick this whole thing to be the R of the aldehyde. So now my R of the aldehyde is going to be a phenyl and a carbon double bond O and a hydrogen in this case. I know that the formula, the general formula of the aldehyde is an RC double bond OH. So that H is a must in the aldehyde in there. So all I need to do is just fill the R part. Plus the leftover in there, which is this guy over here, then this is going to be the R of the Grignard. Let's make it a Grignard this time. Here you go. Or the alkyl lithium, whatever you choose. Both are going to be the same. And this is how you go backwards and prepare the alcohol. Now let's say, for example, if I have a tertiary alcohol. Let's say if I have a phenyl over here. This is an OH. This is another phenyl in there. And that is a CH3. So this guy over here is a tertiary alcohol. And if it is a tertiary alcohol, then I have multiple routes I can go by. Because I know that tertiary alcohols can be made either from a ketone, or from an ester, or from an acid chloride. And the other part of the molecule needs to be either an alkyl lithium or alkyl Grignard. Okay, this is going to be your Grignard reagent. So let's start with the first route of the ketone in there. If you want your starting material to be a ketone to prep this alcohol, then you can choose whatever two R's that you want in there. I can choose the benzene and the CH3 together, of course, with the OH. So for the ketone, let's say, for example, if we choose a whole thing to be the ketone, then in this case, this is going to be the R of the alkyl lithium. So now for the ketone route, I'm going to end up having my carbonyl over here and the CH3. So notice what I did over here. I changed my alcohol, the COH, I changed that into a carbonyl. This is what I did. Let's zoom out a little bit in there. Okay. And now I am going to end up having my alkyl lithium, the phenyl, to be an alkyl lithium in there. I can use, for example, 2 phenols and the carbonyl in there to be my ketone, for example. So I can do that. Here you go. This is going to be my 2 phenols. This is going to leave the CH3 to be coupled with the lithium or the Grignard. Now, as for the esters in there, for the esters and the acidic chlorides, I have to be very specific here because the R's that are added from the ester and the acidic chloride, they have to be the same. So this means that I have to choose both R's that are the same and make them the R of the ester or the R of the acidic chloride. I don't have any other option in there. So for the ester route, I would be starting with, this one is a must. I cannot start with the CH3. I have to start with the phenyl because the phenyl is the one that is added 2 times in there. So that is going to be a carbonyl. Notice the formula for the ester. The formula for the ester is an RC double bond O. It's an OR in there. So I already choose the R, the carbonyl in there. Now the OR, just go ahead and choose any OR that you want. So the R can be any R that you want. I'm just going to go ahead and choose it as an ethyl group in there. After all, this is going to be my leaving group there, plus whatever is left from the molecule in there. So whatever is left is the CH3. This is going to be the R of the organometallic compound. So the R of the organometallic compound is going to be the CH3 there. That is for the ester. Same thing for the acid chloride. I have to choose the R that is the same and make it the R of the acid chloride. So now that is going to be a phenyl. That is going to be a carbonyl, and I know that acid chlorides, they do have a chlorine in there, so go ahead and stick a chlorine. That is going to make your organometallic reagent to be the CH3 Li.